Hi, I'm Robert Jane, originally from England, and I'm a research assistant professor in the Coastal Risk and Engineering Lab at the University of Central Florida. So I did my undergraduate degree in my hometown of Plymouth in mathematics and statistics, and then I did my PhD in civil engineering at the same institution where I looked at the fragility of coastal defense structures. My work concerns flooding caused by the interaction of multiple drivers. So where you have rainfall causing an elevated river discharge, and this coincides with like a high coastal water level. And this is a type of compound flooding. And I really work on analyzing the joint occurrence probabilities of these flooding drivers. This involves fitting multivariate statistical models to observe data or numerical data on the flooding drivers, which enables us to capture the dependence between them, which may be driven by large-scale meteorological forcings. We can then simulate long synthetic records of plausible future extreme events, which can be used as boundary conditions to hydraulic or hydrological models. And there are many potential applications for where this could be useful. For instance, we've done lots of projects with the South Florida Water Management District, where we look at improving their level of service assessment by this better way of sort of capturing that dependence between the drivers. We've also done a project in collaboration with the University of Florida and the US and FEMA's US Coastal Research Program, where we've looked at identifying hotspots of compound flooding on the East Coast and the Gulf Coast of the US. We've also done some more site-specific analysis with the US Army Corps of Engineers. And we've recently been working with the South Florida Water Management District to simulate the full temporal evolution of the flooding drivers, including their relative time lag, so we can put a temporally varying record into these hydraulic models. I wish I knew earlier was the importance of discussing your results with other people, preferably people that you trust, because they can give you really good input. And even if they're not directly in your field, if they're in sort of similar fields, it can really help, give you ideas and improve your work. It's always interesting doing research because you never know what you're going to find. And it's particularly interesting doing research related to natural hazards because our work can contribute to making society and communities more resilient to these natural hazards. If I was not here doing this job, I would probably be in industry. The CoRE lab is great. We have an ever-growing number of researchers with expertise in different areas from all over the world, and it's a really great environment to work in, facilities-wise, and there's really plenty of opportunity for collaboration and working together. It's really a nice place to work.